Hello everyone, welcome to Om Building Automation System. Today we'll take a look at how to design redundancy power source for the control panel. Let's say we will be using functional device power source, and there will be a simple terminal block, simple straightforward end-to-end terminal block, and then we are using a couple of relays. Yeah, let's get started. So the power source from functional device, currently I'm using a PSH series, which comes with a dual power source. So you could use a two single transformers, uh, or the power source that you are using just have to be two source, which can convert 120 VSE or 220 VSE to 24 VSE for the BMS controllers, or any PLC controllers that can accept 24 VSE. So here the PS1 is the primary and PS2 is the secondary. So the PS1 primary is indicated in the red, and PS2, the secondary, is indicated in the blue. Okay, so the red is the hot terminal and blue is also the hot terminal, but let us see how the red terminal is connected and how it functions, which is the primary source. Right. So here in the primary source, right, so you can see it is connected on the terminal block number 1, and you can see it is connected to a relay, which is a 3-pole relay, right? So when the 3-pole relay is energized, right, so the 1B terminal, which is the second terminal, will act as a hot terminal, and that is connected to the pole 11, which connected back as a output on the terminal 3B, right? So that will be your hot terminal for your relay there. From the relay, and that is used as a hot on your controller as well, right? So now because we are using a 3-pole relay, so whenever the primary source gets failed, right, that is PS1, so you can see that it switches back to the secondary source. So the secondary source gets connected on the 12th pole of the relay, and that will act as a hot terminal when primary is failed, and then 3B still stays as hot terminal. So whenever primary fails, you quickly switch to the secondary source. Yeah, of course there is a switching delay. So we will talk about the disadvantage at the last section. What is the disadvantage of this setup? But in most cases, this is very simple setup, and this can be used in most of the control panel, right? So that's the relay 1 3-pole part. So let's say, for time being, relay 1, which is the primary source, is on, right? So you can see that the common of the relay is connected on terminal number 7B, and that goes as a common to the transformer, right? So in that case, right, so we are just making sure from the relay 2 single pole, we are just making sure that the common stays as a common whenever the primary switches. So for example, okay, let us say the primary is failed, okay, and secondary is on. So when the secondary is on, you can see that this relay is activated, so which in turn activates its switch um, to the 22 pole. So 24 pole is during when the secondary source is not activated, and when the redundancy or the secondary source is activated, your 22 becomes the common, and that is how the signal or the common gets connected with your secondary source of the common. So it works in together. So let's say when primary is on, your primary hot and common will be paired, and when secondary is on, your secondary hot and common are connected. Yeah, so this is the simple setup. So we are just using a two source 24 VAC and a couple of terminal blocks and a couple of relays. So that's how you design a redundancy power source. So now there are a few disadvantages. So let's take a look at some of the disadvantage here. Right. Some of the disadvantages are, so there is a switching time. So maybe it's a few seconds, but there is a switching time, right? So during which the BMS controller may turn off. So for that, what is the other solution is, so you can have capacitor banks. So let's say 5 seconds or 30 seconds. So then you could use that uh, as a power source whenever there is a switching between primary to secondary or secondary to primary. So yeah, capacitor banks can be used there. So now most of the device come with proper shutdown, right? So any BMS controller comes with a small amount of capacitance where it can hold the power for certain seconds. So yeah, that's the disadvantage. And in the market, if you are checking functional devices, they also have many redundant power source. So but yeah, the cost is the main part here. It's little bit expensive, but yes, so if you would like to do a simple design which can save you some cost, and so yeah, this approach is very good and it can be used on any controller. Yeah, hope this video was helpful. So please let me know what would you like to know in the field series. So I'm getting started on the field series, and then we'll have probably like a 10 episodes in the field series. So I'll share you a couple of my experience that I went through on the in the field while doing commissioning or point to point or doing programming or some of my work there. Yeah, appreciate your views here. Please subscribe. Thank you. Have a good day. Bye.